Okay, so this is a quick run through of this current version of this point cloud abstract manipulation thing. Obviously, we will change it in the future, but for now, what this version does is it's actually two Niagara systems. One of them is in charge of generating the distance field, and this one we really, I guess, don't really have to move, except for, I think this one you don't really have to move. We have reading in the texture, grabbing the outline with this edge detection thing, and then running the jump flood over it, and it outputs to this render target, which is this one. We then take this render target and read it in our main Niagara system, which is in charge of generating the point cloud, and then based on that SDF we generated over here, we are then spawning points that move with that with the force. So I guess in this example level, how it works right now. And I think we're going to remove this part, so we don't really need it anymore. We do need this part for now, though, in order to still grab the data and references of of our mask. So let's see it working real quick. So ideally, what should happen is right here, as you can see in the blueprint, in the construction script, we have some exposed variables, just so we can debug within the editor. So right now, we set noise mask to 1. Mesh size refers to the mesh of the original point cloud, so this one. And then this floaters thing refers to the spawn particles that we see here. So I guess this is a good time to kind of jump into how the logic of this stack works. It really is just an amalgamation of all the previous versions, so design-wise it's kind of messy, I admit. So anyway, but we're using Niagara's Grid 2D interface to kind of grab our sampling data in order to grab all these textures we have. So all these, from init grid to fill render target, all this is doing is generating a procedural noise texture and applying it on top of our output render target. And that's what this noise mask variable is doing. As you can see, it's generating this noise and then multiplying it on top of this texture. And the original point of this was that so we can have like a particle dissolve animation effect thing going, which we can still use, but for our purposes of having like a more flowy type of vector field type of effect, we just gotta set PT noise mask to 1. DT forces on and off refers to all the forces we're applying here and all the scalars we can apply to those forces. Basically what we're doing is we're first applying this noise mask onto our generated point cloud, and then this emitter here then reads this new generated noisy point cloud texture, and then it's saying if if the pixel I'm sampling is white, or in this case 1, then we can spawn a particle there. We'll spawn a particle in that location and save the UVs of that location, which we are then using this little algorithm, this little scratch pad, to then taking that particle position that was generated in the spawn and then converting it back to a 0 to 1 UV space. Because the idea is that this point cloud is based off this grid from Touch Designer, and we can see that this grid ranges from a 0 to 1 coordinate space, and we're multiplying it by 100 before we send it through Spout to Unreal Engine. So we know our grid size is 100 by 100 essentially. So then we can take this position minus the offsets and get a 0 to 1 UV position, which we are then using that UV to sample our jump flood distance field. And this little bit of math here just returns us a gradient, which is how far that particle is from our position there. So once we have that and we read it, we read this jump flood texture, we can then use that as forces. And then the forces you can access is also accessible here. Do note that since we wanted to, this isn't a really clean distance field we're generating, so all the forces have to be negative. If we want more intense force, if we want something more intense, we can always just add it here. And you might be like, oh, I'm adding a bunch of forces, why is it not doing anything? I would always make sure, look at the drag value first. And that would really help a lot. And then we have two types of forces we're generating. We're generating the straight gradient for one, which means if this is 0, and let's turn curl noise to 0 and drag back to 10. This gradient is really just giving like what this gradient does is it's only finding it down, right? It's finding a position in space and comparing it and applying the forces in that direction directly. Whereas our rotation speed, this provides a force, kind of like circular force, or a rotational force around the thing. But anyway, those are all the values we can play with. I think that's about it for now on this system. Let's see if there's anything else. Oh yeah, one last thing. There's also two versions of this we can potentially play with. One is this one that spawns an outline, but if we want to fill up stuff or we want to play with the size of the outline, we can just switch the mask that we're sampling from, and then this will generate a more whole outline, you know. I need to find out why this one is not working the way I thought. Oh, because I'm not, there's nothing here. I'm not setting it here. That's why. But I'll add that, but that's same shit applies, basically. All right.